In this video, I'll show you why the International Space Station doesn't fall to Earth. It actually is falling, but it's also moving sideways incredibly fast. Gravity pulls the ISS toward Earth, while its sideways speed makes it constantly miss the ground.
This perfect balance creates an orbit.
Imagine running around a hill so fast that you keep circling it instead of sliding down. That's what the ISS does around our planet, turning falling into a never-ending loop high above us.
Picture yourself on top of a huge mountain, throwing a ball. Toss it gently, and it falls nearby.
Throw it harder, and it lands farther away. Now imagine throwing it so fast that, as it falls, Earth curves away underneath it. The ball never hits the ground, it just keeps circling the planet. That's what orbit really is, continuous falling plus. The ISS is just a very expensive, very fast version of that ball, forever looping around Earth.
To really understand why the ISS doesn't fall, you only need two arrows, one for gravity and one for motion.
Gravity always points toward the center of Earth, dragging the station inward. The motion arrow points sideways. When these two arrows are perfectly balanced, the station doesn't spiral inward or fly away. Instead, the ISS is in free fall the entire time, but that sideways motion constantly bends its fall into a smooth circuit here. Even though the ISS is in orbit, it isn't perfectly safe forever. High above us, there's still a thin layer of atmosphere creating drag. Tiny air particles constantly rub against the station, stealing a little bit of its speed. When it slows down, it's orbital. To prevent this, visiting spacecraft fire their engines in what's called a reboost maneuver, nudging the ISS back up into a higher, safer orbit. Without these periodic reboosts, the station would eventually dip into thicker air, heat up, and burn as it fell back to the planet.
A common myth says there's no gravity in space, but that's not why the ISS doesn't fall. At the station's height, gravity...
So why are astronauts floating? Because they're in continuous free fall. Everything on board, the station, the crew, and their tools, is falling together at the same rate. With no floor steadily pushing back on their feet, they feel weightless. The ISS doesn't escape gravity. Its orbit is simply a controlled fall, where sideways speed turns what could be a crash into a graceful...
From the ground, it looks like the ISS simply passes overhead once in a while, but its path is much more dynamic.
The station circles Earth roughly every 90 minutes, completing around 16 orbits per day.
Because Earth rotates beneath it, each orbit passes over a slightly different part of the planet. This creates a sweeping, wave-like pattern of coverage. The ISS doesn't hover over one single country. Its never-ending fall around Earth turns it into a global traveler, offering new views every single lap.
Imagine you're inside an elevator and the cable suddenly snaps. As terrifying as that sounds, you, the elevator, and everything inside would all fall together. That's similar to what happens on the ISS. The entire station and everything in it is falling toward Earth, but moving sideways so quickly that it never reaches the ground. Orbit is essentially controlled, continuous elevator fall that wraps around the whole planet. Getting the ISS into orbit wasn't just about going high, it was about going fast, sideways. Rockets first fight straight up through the thickest part of the atmosphere, but then they start tilting, building horizontal speed. The goal is to reach around 7.7 kilometers per second, fast enough that Earth curves away beneath the paprits. Once this speed is reached, the engines can shut down, and the station keeps moving forward while falling around. Without that sideways sprint, the ISS would simply rise, slow down, and fall right back to Earth like...
Not every orbit is a perfect circle. Many spacecraft travel in slightly squashed, elliptical paths. In these orbits, the spacecraft moves fastest when it's closest to Earth and slowest when it's farther away.
Gravity acts like a cosmic accelerator, pulling harder at short distances and letting go a bit. Engineers can use these changes in speed and height to their advantage, raising or lowering orbits with carefulness. Even when the path isn't perfectly circular, the same idea holds. Motion and gravity work together to...
If you could stand next to the ISS in space, you'd feel almost the same gravity you do on Earth. Inside the ISS, astronauts drift because there's no solid ground constantly pushing back on them. The station moves twice. It's like being on a never-ending roller coaster that's always diving but never hits the ground. That perfect mix of speed and gravity is the secret to why the station stays up.
The ISS doesn't stay at a fixed height forever. Over months, its orbit slowly shrinks because of atmospheric drag. Even though space seems empty, there are still enough air molecules at that altitude to matter. Each collision with those particles... Less speed means a lower orbit. Mission controllers constantly track this descent. By firing engines in the direction of travel, they increase the station's speed, lifting it back into a higher, more...
The ISS orbits much closer to Earth than many other satellites. It flies in what's called low Earth.
Higher up, geostationary satellites sit tens of thousands of kilometers away, where drag is almost non-existent. They move at just the right speed to appear fixed above one point on Earth's equator, perfect for TV and weather monitoring. The ISS trades that stability for proximity, staying close enough for frequent crew rotations, cargo deliveries,
that benefit directly from microgravity.
Inside the ISS, everyday tasks look like slow-motion magic tricks. Astronauts don't walk. They glide, push off walls, and gently spin as they move. Objects don't sit on tables. They float wherever they're left. All of this happens because the station and everything integrates. Microgravity turns the ISS into a unique laboratory, where researchers can study how fire burns. The same physics that keeps the station from crashing, continuous free fall, also creates this incredible...
The ISS wasn't launched all at once. It was built piece by piece while already in orbit.
Like each new module was launched on a rocket, guided into the same orbit, and carefully docked with the existing structure. Despite all this activity, the underlying physics stayed the same.
Every part, new or old, shares the same sideways speed and the same fall.
The entire station moves as one massive object, circling the planet about every 90 minutes and never falling straight down.
The ISS orbits incredibly fast and close to Earth compared to the Moon, which is much farther away. Yet both are essential.
The Moon has just the right speed at its distance to keep circling Earth without crashing into us or flying off into space.
To giant moons, the same balance of gravity and motion keeps objects locked in graceful paths around larger bodies.
If a rocket only went straight up and then shut off its engines, it would simply fall back down. Height alone can't keep you in space.
To stay in orbit, you need sideways speed.
That's why launch trajectories bend, gradually turning from vertical to horizontal as the rocket climbs. The goal is to build enough forward velocity so that, as gravity pulls the craft down, the ISS is the result of that strategy. Not a tower floating above Earth, but a high-speed traveler.
Space around Earth is getting crowded, and the ISS sometimes needs to dodge debris to stay safe. When tracking data shows a potential close pass with a piece of junk, Mission Control can command a small burn. The station's engines or a docked spacecraft fire briefly, changing its speed and slightly raising or lowering the orbit. Even a tiny adjustment is enough to ensure the debris misses by a safe distance.
These maneuvers don't break the rules of orbit, they use them. By carefully changing speed, controllers...
From the ISS, astronauts see 16 sunrises and 16 sunsets every day. As the station falls around Earth at high speed, the planet's surface races beneath them, oceans, continents. This constant motion is a direct result of orbital mechanics.
The same sideways speed that keeps the station from falling to the ground also creates this breathtaking view of a world spinning below. Every lap is a reminder that the ISS isn't hanging in space. It's
syndrome. The height of the ISS orbit is directly tied to its speed. Move faster and you can climb to a higher orbit. This relationship is at the heart of every maneuver controllers perform. When they want to raise the station, to lower it, they can burn in the opposite direction.
The station's ability to stay up is never taken for granted. It's constantly managed through careful control of
Let's put it all together. The International Space Station doesn't float because gravity is weak, it stays up because gravity is strong and motion is precise. The station is always falling toward Earth, but its sideways speed keeps bending that fall into a circle. Atmospheric drag slowly pulls it down, so engines occasionally nudge it back up. Inside, astronauts float in continuous free fall, turning the station into a unique science lab. Orbit is the art of falling forever without ever hitting the ground, and the ISS is one of humanity's greatest